Hello and welcome to Mr. Roberts' revision sessions. This is one of the first ones and it's going to be on CAD CAM. So what is CAD CAM? Okay, so CAD stands for, it's abbreviated to Computer Aided Design. Okay, that's Computer Aided Design. And basically how this works is you take a computer, you use a program or software to generate a three-dimensional model or a two-dimensional model in the virtual space on the computer. Here we have an exploded diagram, very difficult to do without computer-aided design. Shows you where all the parts go. The second image you're going to see is a flow analysis. This is where the air is acting around the model to show you where the turbulence occurs, where you're getting stress from the air, for example. This allows you then to sort of decide on how you are going to develop your design. For example, taking the aerofoil here and developed it into a different design through actual testing that occurs on the computer. So obviously that'll save you a lot of money with wind tunnels and things like that. The good thing about this software is that you can actually generate two-dimensional diagrams as well, so saving you money within one package. So the abbreviation CAM is Computer Aided Manufacture. So in this instance we've used the front aerofoil of a Formula 1 car and use a three-dimensional printer or 3D printer to produce the part, or very similar part in this instance, that can be tested, physically tested, not just using the program but actually tested in real terms. The body of the car has also been produced in a similar way, not three-dimensionally printed, but in this instance using a router, which is a CNC router, and that has produced the body then from balsa wood. So I thought we'd look at different instances or different systems that we can use for CAD. Two-dimensional design packages allow us to do a number of things. We can either do sort of technical drawings for instructions for engineers to make these products or items, or we can use them in art and design for vector art, for example. Banksy uses like a similar theme when spray painting. You can use it for decorations, for cutting out the lettering. You can use it for cutting out numbers for your home, and you can use it for two-dimensional drawings. The construction industry rely heavily on two-dimensional technical drawings still. Two other design systems are including the third-dimensional design systems, which we look at, where we use software that incorporates the depth of a product rather than just the plan view. So we can use flow testing, which is either a liquid or a gas that will travel over a product that we looked at earlier. We can apply a stress analysis, which will tell us where the product will stress or strain or collapse or fail. We can also do solid prototyping, which we can give to users to tell us direct feedback on how they feel the product performs. And we can also use aesthetic analysis to tell us how a product looks and how we can improve the product. These methods are cheaper than the alternative of actually manufacturing the product. So in simple terms, we need to consider all of these machines as being CNC machines, and that means computer numerical controlled. All that means is a code is put into the machine from the computer and it generates what you want it to do. So in simple terms, we use Word, for example, to create a document, then we send it to the printer, and then that printer will print a solid finished article, which is our finished product, on a piece of paper. It's a simple input to output process. There are tons of different types of these CNC machines, and really you need to know, if you're asked in a question what type of CNC machine you would use for a certain process, you need to really know what you would suggest as an answer. So for example, if you were cutting flat stickers, a vinyl cutter is perfect. Vinyl cutters can also print onto the vinyl and then cut around the shape. They also just print on normal reels that are sticky back, for example, like these little sticky dots. So another type is a laser cutter. Laser cutters work in two dimensions. They cut sheets of material You can get lots of different types of material, from high impact polystyrene to acrylic, that will cut reasonably well, with an excellent degree of accuracy. It can be used for creating casings, boxes, and your graphic type products like signage. They also give a professional finish. Another type of CNC machine you might have seen is a two-dimensional router, which has got 3 axes. We say 3 axes because it runs along the X and Y axis across the bed, and the Z axis is introduced for depth or up and down. You can create a range of products with these, really. You can create boxes, you can create signs, you can create really quite strange and elaborate sort of organic shapes. Here you see a book stand that's created by milling or routing quite a few layers of plywood. And this last picture there, you can see there's a model boat being used, and there's a big sheet of plywood. It looks like plywood anyway, and it's routed the pattern out. Now it's great that you can just repeat this design process as many times as you like. The 3D routers, or 5-axis routers or millers, work in the same premise, but they come in at diagonal angles as well, and sometimes the bed of the machine can actually rotate the workpiece that you've got. It comes with a plethora of different tool heads, millers, reamers, different boring systems. You might not know the fact that your iPhone case is actually one billet of aluminium, and then it's cut. So there's over 99% waste on it. It's incredible. It also can create really, really intricate parts like cogs, gears. 3D printers are the big sort of players in school nowadays. They're relatively affordable. The plastic, the PLA we use in there, is very cheap. The great thing about 3D printers is you can just change the model, change the plastic color. It's very intricate if you've got a good quality one. They print relatively quickly. They have excellent capabilities. They're very versatile, and they're great for prototyping. The software takes a while to get your head around, but it's worth it in the end. Right, so CNC lathes. You should have seen a lathe before if you're doing product design or engineering. They take a round or square or hexagonal section of steel or copper or whatever metal material you're using, and it removes an amount of waste to leave you with an intricate design like these chess pieces, for example. The CNC lathes are obviously automated. You use the CAD software to generate the model you want, and it produces it for you. So I mean, the accuracy of these things is ridiculously high. Typical questions on the GCSE paper and sometimes the A-level or AS are going to be advantages and disadvantages. So let's go through a few. They're extremely accurate. CNC devices are extremely accurate. You're going to be hard pushed to get a human to create anything as accurate as you can using this machinery. It can be run continuously, like overnight, 365 days a year, and it really is just a quick production alternative to using labour. Now, there's something called lead time for prototyping, whereas if you sent a model off to a model maker back 10, 20 years ago, they would take weeks and weeks and weeks to produce a product for you, and it would cost a lot of money because you're paying for their time. With regards to prototyping nowadays, your lead time is very, very low. If you think about sending a file to a 3D printer, it might take 3 hours to produce. Most CNC devices will reduce the waste. If you look at a 3D printer, you've got next to no waste using that machine. So they can dramatically reduce the waste, which will save you money. There are skilled staff reductions, whereas you wouldn't, if you had a workshop and you had one CNC lathe, might do the job of 3 trained engineers, which obviously saves money in the long run. And there's plenty of flexibility when you want to manufacture different parts. If you got the 3D printer, again to use an example, it'll print a different part every time you wanted to print something. You don't have to just repeat the same process. If you're using an injection molder, for example, instead, then you'd have to have a new mold every time you want to create a different part. Well, using a 3D printer, it generates it from scratch without the need of a mold. So your big costing with regards to tooling, for example, like mold pieces and things like that, is gone. You haven't got that problem. So disadvantages, there are less of these. They can be expensive. Now, if you're looking at a CNC lathe or a CNC miller, you're talking tens of thousands of pounds. So they can be expensive, but if you factor that against what you're paying an engineer, for example, a year, you would make that money back pretty quickly. And on the same sort of ilk there, you are reducing the labour force. But as a disadvantage, I thought I'd put this in because you are reducing the labour force. You want to employ more people. We don't really want to just keep employing robots to do things. We need people to be employed for the economy, for example. So a reduction in labour force can be seen as a massive disadvantage. Not so much for the company, but for the user, the consumer, and the employee. If we continue to use CNC machinery and robots, we are going to lose skilled engineers, for example, who have spent years and years studying how to be tool makers, etc. We're just not going to need these people anymore, so they're not going to be trained. So we're going to lose these skills in years to come. Now, this is a very dangerous concept. We need to protect these niche skills. If one day, heaven forbid, that we did lose all of this technology, we would have no one to be able to do these tasks by hand, for example, and it would send us right back to the Stone Age in many respects. You will, however, have people who are specially trained to use the CAD software and use the computer-aided machinery, who we need. So you've got to strike this balance where we are keeping these traditional skills alive, but we are actually moving towards creating automated production to be cost effective in the long run. Another main disadvantage is that, like all machinery, it needs to be maintained. CNC machinery in particular is very expensive to maintain. It needs cleaning regularly. It needs maintenance, as in oiling, different component parts changed, for example, just to prolong the life of the machine itself. Thanks for watching. There will be plenty more videos uploaded in the goodness of time, and if you like the video, then please subscribe or give a little like at the bottom, whatever you do. Thanks very much.